Okay, hello everybody. Getting ready to do lesson 5.4 part 2, classwork today, pre-calculus math. Email me here for classwork sheets, homework sheets, PowerPoints, videos, note-taking guides, you name it. Hello everybody. Getting ready to do lesson 5.4, sum and difference formulas, part 2 today. And you have 2 points here of notebook taking. And you got 40 points here for your classwork today. Okay, for today's bell work, teachers and students, today's bell work, find the x and y intercepts of the graph of the equation. Use a graphing calculator to verify your results. Teachers, give your students about 5 minutes here to find your x and y intercepts of these graphs here, of these functions, equations. Technically, there's y equals. And give them 5 minutes and pause your video for 5 minutes and then check back. Okay, welcome back for today's bell work solutions. For number 111, when x equals 0, we plug that in and then we come up with y will equal 4. So y-intercept will be 0, 4. And then when y equals 0, when we have to solve this for 0, we come up with 7. So 7 here. So when y equals 2x minus 9 equals 5. So x will equal 7 or x will equal 2. So your x-intercepts will be 2, 0 or 7, 0 for 111. Down here for 112, when y equals 0, you plug that in here and you come up with, let's see, when y equals 0, you get x equals 0, negative 7. X-intercepts will be 0, 0, then negative 7 and 0. And then when x equals 0, y would equal 0 as well. See, 0 times whatever this is would be 0. So we have 0, 0 as a y-intercept, and an x-intercept will be 0, 0, and negative 7, 0. Okay, moving on now into today's lesson, part 2, 5.4. In your notebook, students, sum and difference formulas can be used to derive reduction formulas involving expressions such as sine theta plus n pi over 2 and cosine theta plus n pi over 2. So sum and difference formulas can be used to derive reduction formulas now involving these expressions here. What are reduction formulas? Where n is an issue. So let's get into a reduction formula, deriving reduction formulas, simplifying each expression. So we have cosine of theta minus 3 pi over 2. So using the formula for cosine u minus v, this is similar, yes? You have cosine theta minus 3 pi over 2 will equal cosine theta cosine 3 pi over 2 plus sine theta sine 3 pi over 2. So when you have a situation like this, it'll derive this formula here using a formula for cosine u minus v. So cosine theta minus 3 pi over 2 will yield this here, following the pattern of cosine u minus v. So when we work through this, cosine theta 0, so cosine of 3 pi over 2 is 0, and then sine of 3 pi over 2 is negative 1, sine theta times negative 1, so we get negative sine theta for this situation. And then when we go tan theta plus tan of theta plus 3 pi, using a formula for tan u plus v, so we have a sum here of a tan function. You have tan theta plus 3 pi will equal tan theta plus tan 3 pi over 1 minus tan theta tan 3 pi. So equals tan theta plus 0, here tan of 3 pi would be 0, and then 1 minus tan theta times tan 3 pi is 0, will equal tan theta, is what that comes out to. Tan theta plus 0, and then 1 minus tan theta times 0. So it'd just be tan theta over 1. So note that the period of tan theta is pi, so the period of theta plus 3 pi is the same as the period of tan theta. Okay, so let's try one now. So verify the identity. So we want to verify that these equal each other, these expressions are equal, and then same thing down here. So again, we go from our sum of difference formulas to derive these. Sine x plus y plus sine x minus y equals sine x cosine y plus sine y cosine x. And then when you plus sine x cosine y minus sine y cosine x. And then when you combine your like terms here, we got 2 sine x, so 2 sine x, so you got sine x and sine x here, 2 sine x plus cosine y. We got cosine y here, cosine x, and then we got a negative cosine x, these cancel, and then cosine y, cosine y, and cosine y. So it'll be 2 times sine x cosine y. This is what that will come out to. And then down here, cosine x plus y plus cosine x minus y. Again, you have the same situation here, where you have factors here that cancel each other out. Cosine x cosine y minus sine x sine y plus cosine x cosine y plus sine x sine y. So cosine x and cosine x, we got 2 cosine x's, cosine y and cosine y, yeah, those, we got those 2 of those too, and then negative sine x, negative sine y, these cancel out here, so you just ended up with cosine x cosine y cosine x cosine y, so 2 cosine x cosine y is how that works. Into our next example here, example 6, solving a trigonometric equation. Find all solutions of sine x plus pi over 4 plus sine x minus 4 equals negative 1 in the interval of 0 to pi. So using the sum of difference formulas, rewrite the equation as sine x cosine pi over 4 plus cosine x sine pi over 4 plus sine x cosine pi over 4 minus cosine x sine over 4 equals negative 1. So sine x cosine pi over 4 equals negative 1. We got some cancel outs here. Sine x cosine, see, sine x cosine pi over 4. See where that stays on. We got 2 of these. Sine x cosine 4. And then over here is another one. And then these 2 cancel each other out. And then these stay the same here. And then when we simplify these, we have 2 of sine x of, and then the cosine of pi over 4 will be square root of 2 over 2 equals negative 1. So sine x equals a negative of 1 over square root of 2. And then we go ahead and we rationalize our denominator here, and we end up with sine x equals the negative of square root of 2 over 2. So the only solutions in the interval of 0 to pi are x equals 5 pi over 4, which will match this exact value here, and x would equal 7 pi over 4. And here is a graph of that situation right here, of the original expression here, plus 1. And so x will equal 5 pi over 4, which is here, then 7 pi over 4 is there. So here's your x-intercepts in actual numbers, which correspond to 5 pi over 4 and 7 pi over 4 for that one. Okay, let's try one. So find the solutions of the equation in the interval 0 to pi. Use a graphing calculator to verify your results. So we have a sine of x plus pi over 3 plus sine of x minus pi over 3 equals 1. And then down here you have this. So let's try this one first. So for this one, sine x cosine pi over 3 plus cosine x sine pi over 3 plus, and then we move into this, sine x cosine pi over 3 minus cosine x sine pi over 3 equals 1. So now we've expanded these two factors here into these. And then we combine like terms, and we end up with 2 sine x. We end up with 2 sine x. Cosine x, negative cosine x pi over 3. That would cancel this one out. And then sine x cosine pi over 3. So pi over 3 is the same thing as 0.5. And then we have 2 sine x is equal 1. And then we go ahead and solve for x. And then x will equal pi over 2 is how we get that. And then down here, we expand these out using our difference formula here into these two factors. And then we combine like terms, and we end up with negative 2 sine x sine pi over 6 equals 1. And then pi over 6 will equal 1/2. Let me continue to solve for 1 here. Negative 2 sine x 1/2 equals 1. And then from here we go to sine x equals negative 1. Let's see here. Negative 2 sine x, sine x. Oh, we multiply these out. So 1/2 becomes, let's see here, will become 2 here. Sine x of 1/2 here equals 1. Negative 2. Sine x equals negative 1, and then x will equal 3 pi over 2. Sine x equals negative 1, and then x, sine, if we divide this negative 1 by sine, we get 3 pi over 2, and then x will equal 3 pi over 2 for that one. Okay, an application from calculus. Verify that cosine of x plus h minus cosine x over h will equal cosine of x of cosine h minus 1 over h minus sine x over sine h over h. So we need to verify this. This looks a lot like the finding slope of the derivative formula for a function in calculus, where h cannot equal 0, that cannot be equal 0 there. So using the formula for cosine u plus v, you have cosine x plus h minus cosine x over h equals cosine x cosine h minus sine x sine h minus cosine x all over h. And then when we combine like terms here, we end up with cosine x cosine multiplied times cosine h minus 1 minus sine x sine h over h here. Once we factor these out here, see cosine x here, and then we have a cosine x over here, minus, so sine x sine h. From this we get there. And then we end up with this here. We've further simplified this. Cosine x cosine h minus 1 over h minus sine x sine h over h. And then cosine x multiplied by cosine h minus 1 over h minus sine x over, sine x multiplied by sine h over h. Examples taken from calculus. It is used to derive the formula for the derivative of the cosine function. So there's your derivative of your cosine function. And then let's try one here. Verify the identity used in calculus. So again, we end up with this here. And to do that, we have sine of x plus h minus sine x over h equals sine x cosine h plus cosine x sine h minus sine x over h. So this here, we use a difference formula here, and then that becomes this down here using our difference formula. And then when we excuse me, when we do a further simplification here, we factor out a cosine h minus 1 on this side here, and then over here we have cosine x sine h all over h, and then this we can separate this out now of cosine x sine h over h minus sine x multiplied by 1 minus cosine h over h for that. And that is your 5.4 part 2. Email me here for classwork sheets, homework sheets, tutoring, or anything else that you need. Thank you very much.